Hello everyone, welcome to Institute Chemistry Genius. Today in this video we are going to discuss about aldol condensation reaction. Okay, so aldol condensation comes in the chapter of your aldehydes and ketones. Okay, so the first is aldol, that means it is taken from aldehyde and ketones. Okay, so aldehyde having alpha hydrogen atom. Aldehyde having alpha hydrogen atom undergoes condensation reaction in the presence of a base, okay, which you can say sodium hydroxide, any strong base if you take, and it is going to give you a product which is beta hydroxy ketone. Okay, so how it happens is that, see, alpha hydrogen means the hydrogen from taken from the carbon atom which is adjacent to the carbon atom containing the functional group. Okay, so the carbon atom which contains the functional group, like suppose it is C double bond O H, that is aldehyde. Okay, and the carbon which is adjacent to it, that is called your alpha hydrogen. That carbon which contains hydrogen which is alpha to the carbon which is having functional group is not taken as your alpha carbon, but adjacent to that carbon is called your alpha carbon. So, and then you are going to get a product which is your beta hydroxy aldehydes. Okay, so beta hydroxy, that means alpha carbon will be the carbon which is which is adjacent to the carbon containing functional group, then another one carbon adjacent will be your beta carbon. So in beta position, that you will have a hydroxyl group as the product. So see here, if you take this aldehyde, suppose CH3 C double bond OH, and again if you take the same molecule, you can take different molecules, so you will see different products, but now we are going to take same molecule only. Okay, and I will say you why different products gives you different answers. Okay, and which is actually helpful and which is not. So see here, in beta position we are going to get a hydroxy group. Okay, and the carbon containing alpha is the carbon which is next to the carbon containing your carbon containing the functional group. So same here, similarly, if you take a ketone, see now if I take acetone, see this is the simple molecule CH3C, the C double bond O CH3. Okay, if you take this again, you are going to get CH3COH, CH3, CH2, C double bond O, and CH3. So this is your beta hydroxy ketone formation and beta hydroxyaldehyde. These are the two products you're getting. Okay, so let's see the mechanism, how and why we are getting these kind of products. So in mechanism, the first step is your protonation. Okay, so see, since here it is base catalyzed reaction, whenever you are going to take a base catalyzed reaction, that means the catalyst or which is going to start the reaction is your base. So that base, that is NaOH or whatever you have taken, so that OH minus is going to take a hydrogen atom which is from the alpha carbon. Okay, not from the carbon containing functional group, but from the carbon which is adjacent to your alpha carbon. So that carbon whichever hydrogen is there, it is going to abstract a proton from alpha carbon, okay, of the carbonyl molecule to form your you have resonance stabilized carbanion. It will form because it is going to take up hydrogen is lost, so that hydrogen goes out as proton always, H plus it goes out and it will form water. So you are going to get a carbon ion, that means minus ion will be there in the molecule. So this way you are going to see this product. Now see, if you write the reaction in this way, like if you split the hydrogen of this molecule, and there is a simple one, take a hydrogen, so the hydrogen is going to go away as water molecule, and this is going to give you CH2 minus. So this is the carbon ion which is formed, and this minus ion will come into the resonance. See here, it will come into the double bond, it will come in a double bond formation and O minus, so it is going to be resonance stabilized. Okay, so resonance is taking place here. So now what happens, so this is a very stable molecule. Now this step 2 is like this carbon ion which is formed as an intermediate, this is going to go for nucleophilic attack. So then it was going to go for nucleophilic attack. Now you don't have any more you can say you don't have OH minus to attack right now. Now you have another electron rich molecule, that is a nucleophile. So what does the nucleophile do? It will go and attack the electron deficient center. So electron deficient center, here it is the carbonyl group. Okay, that means now the carbon which contains the functional group will take part in the reaction. So CH2 minus C double bond OH. Now this minus is going to attack this carbon atom. Okay, and now what happens is that you are going to write like this: CH3 O minus. You just write in the same pattern, don't remove, don't change anything. You are not never going to miss anything in chemistry questions. Okay, now see what happens is that this O minus, what it will do again, it will take up a proton from water molecule which is present in the reaction medium. So now this is going to see beta hydroxy ketone. Is it not that OH is there in the beta position you have got through mechanism? So this way you are going to get your product. So if you like this video, do watch other videos from the channel, and if you want me to make some specific videos on some best specific topics, please do write in the comments. And if you want videos in Hindi, whoever is seeing that, then please do write in comments so that I can make also videos in Hindi for all of you. Thank you so much.